In this episode, we look at malware indicators, which are signs that malicious software may be present or active in an environment. Malware is a broad word for software or code designed to harm systems, steal information, disrupt operations, spy on users, or give attackers unauthorized control. You do not always see malware directly. Instead, you often notice symptoms. A workstation may become slow. Files may be renamed or encrypted. A browser may show strange pop-ups. A user may report missing data. A security tool may detect an unusual process. A server may contact an unfamiliar destination at odd hours. These clues are called indicators because they point toward possible malicious activity, but they still need investigation. One symptom alone may have an innocent explanation. Several symptoms together can tell a stronger story. The goal is to learn what common malware families tend to do, so you can recognize when normal system behavior no longer looks normal. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at Cyber.Me in the Bare Metal Study Guide series. Ransomware is one of the easiest malware categories to picture because the symptoms can be very visible. Ransomware is designed to deny access to systems or data, usually by encrypting files and then demanding payment for a recovery key. An encryption notice is one of the clearest indicators. A user may suddenly see a message stating that files are locked, that payment is required, or that data will be released if the organization does not respond. File names may change, extensions may look unfamiliar, and documents that opened normally yesterday may no longer open at all. Shared drives may show thousands of files changing quickly. Systems may slow down because the ransomware is reading, modifying, and encrypting large amounts of data. Backups may be targeted too, because attackers want to increase pressure. Ransomware is not always immediate chaos, but when encryption begins at scale, the signs can become loud very quickly. Ransomware indicators can also appear before the encryption notice. Many ransomware incidents begin with earlier activity such as stolen credentials, remote access misuse, privilege escalation, discovery of network shares, and attempts to disable security tools. Privilege escalation means gaining higher levels of access than the attacker originally had. Attackers may spend time finding valuable systems, locating backups, identifying sensitive data, and preparing to maximize damage. You might see unusual logins, especially outside normal work hours. You might see administrative tools used by accounts that do not normally use them. You might see large amounts of data compressed or transferred before encryption starts. You might see security services stopped, event logs cleared, or endpoint protections tampered with. These early signs matter because stopping ransomware before encryption is far better than responding after the message appears. The visible ransom note may be the final stage of a longer intrusion, not the beginning. Trojans are malware that pretend to be something useful, normal, or harmless while hiding malicious behavior. The name comes from the idea of a gift that secretly contains danger. A Trojan may arrive as a fake installer, cracked software, game tool, invoice viewer, document helper, browser extension, or system utility. The user believes they are opening or installing one thing, but the program performs hidden actions in the background. Indicators of a Trojan can include a new program the user does not remember installing, unexpected startup entries, strange network connections, changes to browser settings, new scheduled tasks, or unknown processes that reappear after reboot. A Trojan may steal credentials, install additional malware, open remote access, capture information, or act as a downloader for later payloads. The important clue is deception. The software presents one identity to the user while doing something else for the attacker. Worms spread themselves from system to system, often without needing each user to manually run the malware again. A worm may exploit a network weakness, use shared folders, abuse weak passwords, or copy itself through removable media. The indicators often include rapid spread, repeated connection attempts, unusual scanning behavior, and many systems showing similar symptoms around the same time. Network traffic may spike as infected systems search for more targets. Logs may show repeated failed connections to many hosts. Devices may become slow because the worm is using processing power and network bandwidth. A worm can be especially disruptive because one infected machine can become a source of infection for others. This is different from a single malicious file sitting quietly on one device. A worm is active and self-propagating. If it is not contained, the problem can grow quickly across networks, offices, or connected environments. Spyware is malware designed to collect information without the user's informed consent. It may monitor browsing activity, capture credentials, read messages, collect documents, record screen activity, track location, or gather system details. Spyware indicators can be subtle because the attacker usually wants the spying to continue unnoticed. A user may notice poor performance, unusual browser behavior, unexpected permission prompts, strange applications, or increased network activity. Security tools may detect processes trying to access sensitive browser data, credential stores, microphones, cameras, or files. In some cases, spyware may create persistence so it starts again after reboot. Persistence means the malware has a way to remain active or return after the system restarts. Spyware is dangerous because the damage is often not obvious immediately. The system may still function, but private information may be leaving quietly. When the goal is observation, silence is part of the attack. Adware is software that displays unwanted advertising, redirects browsing, changes search settings, or injects marketing content into the user's experience. Some adware is more annoying than destructive, but it can still create security and privacy risk. It may track browsing behavior, collect data, install browser extensions, change the homepage, open new tabs, or push the user toward unsafe sites. Indicators include excessive pop-ups, browser redirects, new toolbars, unfamiliar extensions, changed search engines, and advertisements appearing in places where they do not belong. The device may slow down because the adware is loading extra content or communicating with advertising networks. Adware can also arrive bundled with free software where users click through installation prompts too quickly. Even if adware does not steal files directly, it reduces trust in the system and may expose the user to more dangerous content. A messy browser can become a gateway to larger compromise. Viruses are malware that attach themselves to legitimate files, programs, or documents and spread when those infected items are executed or shared. A virus usually needs some form of user action or program execution to continue spreading. Indicators may include corrupted files, programs that crash, unexpected changes to file size, security warnings, disabled protections, or infected removable media. Files may behave strangely because the virus has modified them. A system may become unstable if important files are altered. In older environments, viruses often spread through shared disks and files. In modern environments, they may still appear through documents, scripts, downloads, or compromised software packages. The key idea is attachment and replication. The virus hides inside or alongside something else, then uses that host to spread. Not every malware infection is a virus, even though people often use the word virus casually. In security work, the distinction helps you understand the behavior. Rootkits are especially serious because they are designed to hide malware activity or give attackers deep control over a system. A rootkit may modify system behavior, hide files, conceal processes, intercept system calls, or make malicious activity difficult to see through normal tools. Indicators can include security tools failing unexpectedly, system commands giving inconsistent results, hidden accounts, unusual drivers, strange boot behavior, or evidence that logs do not match what other monitoring shows. A rootkit may operate at a privileged level, which makes detection and removal harder. The system may appear normal to the user while the attacker maintains hidden access. Rootkits remind you that absence of evidence is not always evidence of absence. If a system is suspected of deep compromise, defenders may not fully trust what that system reports about itself. In serious cases, rebuilding from a known good source may be safer than trying to clean only what is visible. Keyloggers are malware or malicious tools that capture what a user types. The most obvious target is credentials, but keyloggers can also capture messages, account numbers, search terms, commands, and sensitive business information. Indicators may be subtle because a keylogger wants to collect data quietly. You might see an unknown process running in the background, suspicious access to keyboard input, unusual files storing captured text, unexpected network connections, or security alerts from endpoint tools. A user may not notice anything at all until accounts are misused. Some keyloggers are software-based, while others can involve hardware placed between a keyboard and computer, though hardware cases require physical access. The risk grows when a keylogger runs on a device used for banking, administration, remote access, or identity management. A stolen password is serious. A stolen password plus captured one-time codes or administrative actions can be even more damaging. Logic bombs are malicious code designed to activate when a specific condition is met. The condition could be a date, time, user action, account status, file change, or other trigger. A logic bomb may delete files, corrupt data, disable services, create accounts, or perform another harmful action once triggered. Indicators before activation can be difficult to notice because the code may sit quietly. After activation, the symptoms may look like sudden deletion, unexplained failure, data corruption, or system disruption. Logic bombs are sometimes associated with insider threats because someone with legitimate access may plant code that activates later, perhaps after they leave the organization or after a certain business event. That does not mean only insiders can use them, but trusted access can make placement easier. The security challenge is that delayed action separates cause from effect. The harmful event may happen long after the code was introduced. Fileless malware is a category that often confuses new learners because the name can sound as if nothing exists. Fileless does not mean there is no malicious activity. It means the attack relies less on traditional malicious files written to disk and more on memory, scripts, trusted tools, or built-in system features. Attackers may use legitimate administration tools in harmful ways, run commands in memory, abuse scripting environments, or use existing processes to avoid leaving obvious files behind. Indicators include unusual command execution, suspicious script activity, unexpected child processes, strange use of administrative tools, encoded commands, abnormal network connections, and persistence mechanisms that do not look like a normal installed program. Fileless malware is difficult because traditional file scanning may miss it. Defenders need behavior-based detection, logging, and careful attention to how normal tools are being used. The danger is not the tool name. The danger is the intent and behavior. Unusual processes are a common malware indicator across many categories. A process is a running instance of a program. Some malware runs as a process with a strange name, while other malware uses names that look similar to legitimate system processes. A suspicious process might appear from an unusual folder, run under the wrong user, consume too many resources, connect to unknown destinations, or restart after being stopped. You might see a normal tool running in an abnormal way, such as a scripting engine launched by an Office document or a remote management tool started by a standard user account. Process indicators should be judged with context. A process that is normal on an administrator workstation may be strange on a receptionist's laptop. A process that runs during scheduled maintenance may be suspicious at midnight from an unexpected account. Malware detection often begins by noticing that behavior does not match the role, time, or system. Abnormal resource usage can also point toward malware. A system may show high central processing unit, CPU, usage, heavy disk activity, high memory consumption, unusual network traffic, or battery drain on mobile devices. Ransomware may create heavy disk activity as it encrypts files. Worms may create high network usage as they scan or spread. Spyware may send data quietly, but still create unusual outbound connections. Adware may consume browser resources. Cryptomining malware, which uses a system to generate cryptocurrency for the attacker, may drive CPU or graphics processing unit, GPU, usage unusually high. Resource spikes do not always mean malware. Software updates, backups, indexing, and legitimate business applications can also use resources. The value comes from comparing the behavior to what is normal for that device and user. Abnormal resource usage is a clue that deserves investigation, especially when it appears with other indicators. Persistence is one of the strongest signs that malware is trying to survive. Malware may create scheduled tasks, startup entries, services, registry changes, browser extensions, hidden files, modified shortcuts, new user accounts, or changes to authentication settings so it can return after reboot or user sign-in. Some malware may reinstall itself if only part of it is removed. Others may hide behind legitimate names or locations. Persistence matters because it shows the attacker wants lasting access, not just one temporary action. When a system is cleaned but the same symptoms return, persistence should be suspected. Defenders look for how the malware starts, what account it uses, what files or settings support it, and whether it connects outward after startup. Removing the visible malicious process may not be enough. The mechanism that brings it back must also be found and removed, or the infection may continue. As you continue with Security Plus version 8 and SY0801, remember that malware indicators are signs, not automatic conclusions. Ransomware may show encryption notices and renamed files. Trojans may appear as useful software while hiding malicious behavior. Worms may spread quickly and create scanning traffic. Spyware may collect information quietly. Adware may change the browser and flood the user with unwanted content. Viruses may attach to files and replicate. Rootkits may hide activity at a deep level. Keyloggers may capture typed information. Logic bombs may wait for a trigger. Fileless malware may abuse trusted tools and memory rather than obvious files. Across all of these, you should watch for unusual processes, persistence, abnormal resource usage, strange network activity, disabled protections, unexpected file changes, and user reports that something feels wrong. Good security thinking connects symptoms into patterns, then investigates calmly before deciding what happened.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.